For being here. Today's the fourth session. I'm going to tell a little bit more about smart contracts and dApps. Probably one of the first things if you start reading about blockchain technology that pops into mind. I'm going to go a bit more in depth today, so hopefully after this session you know more about what it is and how they can be used. Today is Edward and Bogdan who's going to present, so I want to ask them on stage. You guys can take it away. Cool.
Hi everyone. My name is Edward. I'm happy to see that there are some people here, although not as many as last time, but it's good that we have the true blockchain pioneers. So, getting right into it, today we're going to cover some topics. We're going to start talking about Bitcoin, then we're going to cover wallets, Ethereum, a blockchain platform, smart contracts. Bogdan is then going to talk about dApps, tokens, advantages and disadvantages of smart contracts, and then we're going to have a little talk about what we think about this technology, and then we're going to move to the Q&A. So, about Bitcoin. You might be wondering why Bitcoin, it's smart contracts and dApps. Bitcoin was the first blockchain platform to be widely used, and it's actually the simplest one to explain and understand. So, what you really need to get from this slide is that in Bitcoin, there's just transactions between two people at a time. So it's two people, then two people have another transaction, and so forth. The Bitcoin blockchain, as explained in previous sessions, is just a blockchain that consists of blocks that hold transactions, and miners that are trying to solve the puzzle, trying to add transactions to the blockchain and mine a new block. Now, what you need to remember is that there's only transactions included, right, in the Bitcoin blockchain. So then, how does the average Joe get to know what balance he has, right? Because there's no balance written down in the contract. Well, that's when we go to wallets. And contrary to popular opinion, wallets actually don't store any currency or balance. They're just a user interface that helps people see into the blockchain what balance they currently have. And they're also used to send commands to the blockchain in this case, and to smart contracts, which we are going to explain later on. Now, wallets. What they actually act like is binoculars, which help users speak into the blockchain, draws some conclusions, some results from the blockchain, and then shows it in a user-friendly way back to the end user. Now, how this is calculated, and we're going to refer to them as wallets, not binoculars, because it's easier, is they actually check each block for transactions. And looking at the first block, you can see that Mark sent me 12 bitcoins. Then there's some transaction between Luke and Mark, which has nothing to do with me. And then I send Luke 7 bitcoins. So it calculates that I have 5 bitcoins. And that goes on and on for each block, and it checks each block each time you ask it to update your balance, to check what balance you have. And then in the last block, it can see that I received 4 extra bitcoins from people. So my final balance is 8 bitcoins. Now, a wallet actually acts like a bank account in some way. For a bank account, we have a PIN number and an IBAN account. With the PIN number, then you can send transactions, right? And with the account number, you can receive money or transactions, and it's actually a unique identifier for you. Now, that kind of stands for wallets as well. There is a private key, which kind of equals to a PIN number, and also a public key, which equals to a unique identifier that people can see you with. Now, using this private key, the wallet can sign transactions, initiate transactions to the blockchain, send them, and that's how transactions are made from one wallet to another. Now, Ethereum. Why I initially explained blockchain is because you need that basic knowledge to understand this blockchain, which is kind of an upgrade from that one. Now, Ethereum Yeah, the initial image that I showed, this is what happens in Bitcoin's blockchain. And in Ethereum blockchain, what happens is actually the same. It's just that there's an extra entity there called smart contracts, which we are going to go in depth in, I think, not the next one, in 2 chapters. Now, Ethereum. It's a blockchain platform. It uses blockchain to do all its math and activities. Acts like a computer. It's distributed, and such it gets its power from its participants in order to compute all the transactions or actions sent to it. And last but not least, it runs programs called smart contracts, which we're going to explain. Now, in Bitcoin's blockchain, we have a number of transactions which link to another block with other transactions. But in Ethereum's blockchain, we also have those smart contracts here and there. It can be a block consisting only of smart contracts, that's possible, but usually there's also transactions, just like Bitcoin. Now, what are smart contracts? In a way, they're not smart, neither contracts, but in another way, they can be artificially smart, as in they have pre-programmed decisions that they can do, like a smartphone, for example. It takes what you give it and then makes some calculation, then it spits out an activity. And in another way, they can sometimes act like contracts because they have rules that they live by, and those rules cannot be changed. Hence, it lives on the blockchain, and it inherits some characteristics such as immutability, decentralization. But in the end, they're just programs that live on a platform. By coincidence, actually not by coincidence, they live on the blockchain. Now, smart contracts, as a quick example of how people interact with them. Let's say we have an average Joe here who wants to put something on the blockchain. In this case, it's a smart contract. And note that anyone can put any smart contract on a blockchain. Once it's put there, it goes into the specific block that it's mined into, and then the blockchain keeps going. So it stays at the point when it was put into the blockchain. Now, since it's on the blockchain, it has a unique identifier, an address, hexadecimal, with which users can access it. They can reach it with that number. And let's say this guy here wants to interact with a smart contract that's on the blockchain. Now, he cannot do that directly, so via his wallet, his private key, he can initiate transactions. And with the same wallet, he can actually initiate actions or send commands to the smart contract. He can either send commands, he can send tokens, data, or whatever that smart contract allows. How he sends it, he sends it to the address of the smart contract, to the unique identifier. Now, once the smart contract receives some info, some data, it has to decide what it has to do with it. So it runs the function that was called from it, hence its code. And then once it decides what to do with it, it spits out some response to the wallet. The wallet then translates that info into human readable information and spits it back to the initial user. Now, as a more tangible example, we have this. You all know about Kickstarter, right? Now, Kickstarter is a platform that helps creators get money from funders and then rewards them in some sort of way. Now, what smart contracts can do is remove the middleman, in this case Kickstarter, from the equation. And let's suppose the smart contract had a rule saying, hey, we can give this money to the creator once a certain threshold is reached. So those people send the money to the smart contract, and then the smart contract decides whether that threshold was met in a certain amount of time, or if it wasn't, or if that time was passed and the threshold wasn't reached. If it was reached, then the project is funded and the creators get their money. However, if the threshold is not reached and it fails, then all the funders get their money back. How this works and why is it safe is because the smart contract is programmed, so it doesn't have a central authority to decide what to do with the money. It's pre-programmed to decide what to do with the money based on variables and indices it gets from real time. Now, dApps, Bogdan is going to talk about them, and they make use of smart contracts in day-to-day activities.
Hey everyone, I'm Bogdan. I'm gonna continue from where I started, left actually. Yeah, so as Eddie said, the Ethereum blockchain can hold smart contracts on it. So this is how a smart contract would look on a block. dApp, also known as a decentralized autonomous application, is actually an application that's built on top of that smart contract. This way, the smart contract actually works as the logic for the application, while the application is just the interface. So, if my application has two functionalities, one would be to make a payment and another one to request one, to make a payment request, each of these functionalities would be linked to functions that are predefined in the smart contract. How many of you have been to the use cases in the digital marketing workshop, the third workshop here? We've discussed some of the projects here, and 3 out of these projects, so all of them except VeChain, are actually dApps that are built on top of smart contracts with the help of certain platforms such as Ethereum. Now we're going to look a bit into tokens and what are they. So a token is basically just a cryptocurrency, or acts like a cryptocurrency, but it's integrated in a smart contract. So all the functions defined in the smart contracts and a dApp that is built on top of a smart contract can use those tokens. The difference would be that while in a regular blockchain such as Bitcoin, only transactions that exist and a wallet scans those transactions to see the balance, in a smart contract there is kind of a list with all the tokens holders and how many tokens each person has. So if I would want to make a payment towards Edward in this situation, I would not initiate another transaction and then scan the entire blockchain to calculate balance, but my balance would just reduce with 5 tokens and Eddie's balance would increase with 5 in the list that the smart contract holds. Yeah, just like this. So, if we were to discuss some advantages and disadvantages of smart contracts, one of the advantages would be the immutability of it. So, since it's on a blockchain, like everything else, it cannot be changed. Everyone who holds a copy of the blockchain and acts as a node and mines the blockchain also holds a copy of the smart contract. So the smart contract cannot be lost and cannot be changed. The fact that it runs automatically, it takes out the intermediary guy, which reduces costs and improves its economy. As Edward also said, smart contracts are basically just software programs. So they're executed really fast without needing too much processing time. And since they're on the blockchain, all the participants and everybody who wants to use the smart contract is granted to look at the same copy of the smart contract. So, how do I say it? There's no disputation between the parties involved in the smart contract. So a real use case of a smart contract is the Fees Insurance Company, which is a flight insurance company. They have a smart contract which gets uploaded with data from airline companies on real time. So their policy is that if your flight is delayed more than 2 hours, you automatically get paid with the insurance money that you've been promised. So you no longer have to ask for the money that you've been promised, you don't have to go through all the paperwork. They just get the data, and if your flight is delayed, you automatically get paid in your credit card. Yeah, some of the disadvantages of the smart contracts would be the human factor. So the smart contracts are written by humans, and humans make mistakes. If you do one, it's going to be there on the blockchain, and you're not going to be able to change it. Implementation costs is also a disadvantage, since not everybody can write smart contracts. You need a technical background and some programming in order to write it properly. So if you don't know that, you're probably going to need a programmer to do it for you, and he's not going to do it for free. Suspiciousness is also a bad thing here, since in order to properly understand the advantages of a smart contract and trust that it will work properly, you need to understand how it works and how a blockchain works. And this is not a very easy thing for everyone. And yeah, here immutability is also a disadvantage. So I also said it as an advantage, but if you write something bad, you won't be able to change it. And yeah, we'll go through an example where a smart contract went wrong. So maybe you've heard of the DAO attack, or the DAO debt. It was supposed to act somehow like an investment fund, where users could send money to a smart contract, and once a certain threshold was reached, that money, some projects could pitch their ideas to the users who invested money, and based on the votes received from those users, their projects will get funded or not. So each user who has invested some money will have a say in the project's investment or not. If the project makes profit, so do the users who invested money. That was how it was supposed to work. But in May, this project started in May 2016, and for a period of a month, they gathered money from 11,000 users. In total, they managed to get 12 million ethers, which at that point was worth $150 million. And at that time, Ethereum was still trading at $15. Just as a fun fact, now it's $150, and its all-time high was $1,300, if I'm not mistaken. So a lot of money was raised. The thing is that the smart contract who held all this money had a small bug in it. Someone was able to identify that bug and was able to retrieve from the smart contract $70 million, which couldn't be recovered, basically. Some people argue if this guy was a hacker or not, because he didn't really do nothing bad. He just made use of the rules that were programmed in the smart contract. Another problem with smart contracts would be transacting real life assets. So if I want to buy a car with a smart contract, but I don't want to pay it unless I know that the car works properly and is in a good condition and the engine is good, how does a smart contract know when to pay the seller? Because it can't analyze all these things in real life. The solution for this would be an oracle. So an oracle basically acts as the eyes of the smart contract. He tells the smart contracts the things from the real life. But the problem here is that all this power would stand in the hands of one person, and that person could basically decide the outcome of the smart contract. So it kind of loses its point because it's no longer decentralized, it's centralized in a way. People are looking to solve these problems, and there are different platforms that are already implementing solutions for this. But yeah, this still stands as a problem here. So our opinion on smart contracts, it clearly brings a lot of advantages if used properly and only in the best cases. So you shouldn't use it when transacting real life assets or yeah. Other than that, if used properly, they can bring good improvements. Yeah. Questions? It was kind of short, or shorter than the other ones, but
Any questions?
maybe we went through some things a bit faster than we expected to.
I'm just wondering how smart contracts is actually a solution and if it needs to be controlled in some way. So it seems to make the things more difficult.
I guess it depends on the way you use it. Like the example that Eddie presented in the crowdfunding thing that would replace Kickstarter, no one would have to control the smart contract. It's just those rules would be predefined in the smart contract and they would execute themselves automatically. There's no person who would have to say if the threshold for a project has been reached or not, or if the time has expired or passed. The smart contract can do those things by itself and it can self-enforce. But yeah, when buying a car, that's something else. So when used with digital assets, they can work pretty good, but with real life assets, there's still these problems that needs to be solved.
But also in regards to the flight data, the delays,
Yes.
the 2 hours, who determines
Oh, there
how
are,
long the
there are,
flight is delayed?
for example, there are databases that record all the flight information in real time, and they were going to base all these decisions based on those online databases. So
Yeah, but which database, and can you tamper with the data before it's hit?
yeah,
How is the connection made? And what if the database moves to different locations and the address changes? How does the contract account for that?
yeah, that could be a problem. So you need a good source of information in order to use the smart contracts, because if you feed it with the wrong information, the smart contract can't judge by itself. It will just execute. So yeah, it's a good point. You need a reliable database in this case.
The thing is, there's really a niche where smart contracts are applied. And most use cases we actually found are within the crypto space, because of course that was the first big thing to happen to crypto and smart contracts, and that led to more discoveries into how this technology can be used there. And it's used in managing some money, it's used in transferring some money, and we couldn't really include those examples because they're kind of niche. But the thing is, once some of the problems are solved, such as the Oracle problem, or the checking of whether the data is valid for the flight information, then it could be moved to new areas of activity.
Especially with Internet of Things, it develops pretty well. If you sell a car, the car may talk to the smart contract and say, I've been sold to this guy, and then the smart contract executes. So this could be useful for physical assets, not digital.
With the database, with the external data set, with the API call that needs to be made, there's still some problems there, and because you have the dependability on the external data source that can be changed.
In your example with the with Kickstarter, who makes a smart contract?
Anyone can make the smart contract. It's just that people have to use it. people have to use the same one. Because if there's 10 smart contracts of different versions who try to do the same thing, then people will use different ones. So usually, and nowadays, there's usually a central authority that decides what smart contract to use. The smart contract is actually used more sort of a proof to people that it's open source and that it's fair. Right? No one can control it. Everyone can see the source code.
But how do you make sure that the smart contract is easy to read? I mean, it functions to remove the middleman, at least that's part of it, but how do you prevent that there's a long list of exemptions in which it doesn't work, like in the case with the flight? There must be some exemptions in of cases where it doesn't apply, but people have to understand it, right? How do you make sure it's easy to
You mean that you need to be able to read programming language?
No, I mean, nowadays we also have contracts, but they're sometimes 50 pages long. How do you prevent a smart contract from becoming that long and easy to use?
Yeah, I'm not sure about that.
It doesn't necessarily shorten real-life contracts. It just brings programming alternatives or bonuses to traditional contracts in that sense.
Mm-hmm. But the thing you said is that people can directly interact with the smart contract, right? So that's why it removes the middleman, because people can directly interact with the smart contract.
Yeah. And they know what response they're going to get even before sending. If they look at the code, yeah, that's another limitation. In order to check that the code really sends something valid, you need to be able to read the code that was written there.
All right. So you have to be able to understand some coding language.
Yeah. Or then you would have to call another middleman that would have to
Yeah.
explain to you the
That
code
was
and
my
what it
point.
means.
Yeah.
Yeah. That's another limitation. You need to understand some sort of, have some sort of coding experience.
The point is that it cannot be modified, or that all the parties that want to use the smart contract and they are all looking at the same copy of the smart contract, and no one can modify it for its own purposes. I would say that's a bit more important than having someone else read it for you.
But for your first question, it isn't like the contract itself and all the rules and all the laws doesn't change. So if there are like 15 pages of exemption, they still exist. So like transferring that kind of contract to a smart contract doesn't make it easier on the law side. You know what I mean? So yeah, for more simple things, I think it's only suitable. Only it's most suitable for really easy. Okay, if this is the input, this condition is met, then this is the output.
Yeah.
Yeah, for now it's a really small niche that it can function. It doesn't replace contracts at all.
Alright.
It's actually, you can of course include some text in it and use it as a contract, as is, but it's made to be a program actually.
Have you thought about use cases in online marketing for smart contracts?
Well, kind of all these, all those projects are based on smart contracts, so battery and basic attention token and ad shares. They're all programs that are running on smart contracts. They use blockchain just to register the information that they are making.
Did you also think about like new things that could be developed or something like that for online? Because
Yeah.
you're probably busy with it all day, so.
Yes.
We're
That's what we're working on at
Yeah.
Labs actually. But we have a whole presentation for this.
Just give them a heads up.
No spoilers.
So we're kind of looking at an identity management tool in which users can share their data directly with publishers through the use of smart contract. So how it goes is that the user would put his data on the smart contract, make it available for the publisher, and then the publisher can access the user data from the smart contract and reward the user back through the smart contract again.
Okay, go ahead.
Tell us something about your life.
My life was very hard up until now. I was born and raised as a black child in the lands of Ethiopia.
Stop for a second.
Wait, I can plug in my headphones and I hear.
Oh yeah?
Yeah.